Here we are at our example 1 from our classifying triangles notes. Now, before we really dive into that example, what we're going to go ahead and do is first look at the definitions for these, and then that'll help us out with our problem. So, for our first triangle that we noticed right here, we have an acute triangle because all of these different angle measures inside are less than 90 degrees. So that's why it's called acute. Whereas the next one, we notice that we have one of those angles being an obtuse angle, and so that's why we call it an obtuse triangle. Our third triangle, we notice that we have this right angle right in that corner right there. It doesn't have to be there, but we do see that this is a 90-degree triangle because it has that right angle. So that's why we call it a right triangle. And then the last one is we notice all of these different angle measures are exactly the same. And so that's why we call it an equiangular triangle. Okay, and that's where, again, those three congruent angles kind of come into play. We call it an equiangular triangle. So again, those are just the angles, the different types. So you got acute, obtuse, right, and equiangular. Now let's go ahead and look at the different sides. So if there are no congruent sides on a triangle, we call that a scaling triangle. Okay, it's typically the most common type that we encounter. The second one, though, is where we see two sides that are exactly the same. That's what those little tick marks mean. But that third side is not necessarily. So this base right here, you can see that it's not the same as the other two. Otherwise, it would have a tick mark. And so what we call that is an isosceles triangle. Isosceles triangle, believe it or not, on practice ACT questions, I have seen it. So it does make appearances. Now, the last one, though, is what we call an equilateral triangle. That's where all three sides are the same. So those are all three congruent sides. So now that we have seen some definitions based on the different angles as well as the different sides, let's go ahead and look at example 1. And what we're asked to do is classify each triangle based upon their angles and by their sides. So when we look at example 1A, we do notice that we see this 115 degrees right there. So when we're talking about the angles one, we would see that is actually an obtuse triangle because it does have that one obtuse angle in there. So we're going to call that an obtuse triangle. And now let's look at the sides. Well, all of the different sides we don't really know. But they're not going to be the same just because the angles opposite of them are all different. And so as a result, none of our sides will be the same. So your side lengths are in direct proportion with the angles opposite of them. And since none of our angles are, none of them are the same, then none of the side lengths opposite of those are going to be the same. So as a result, since we have three completely different side lengths, that is a scaling triangle. So notice the first one we mentioned just focused on the angle measures, whereas the second part we focused on the actual side lengths. So now let's look at B. We do notice that we have these two congruent side lengths, and because all of those are under 90 degrees, this is an acute triangle right here. So we have an acute triangle. And because the two angles and the two sides opposite of those angles are exactly the same, that is going to be an isosceles triangle. In the future, I think I'll just probably denote this as like a little triangle. Now, when we look at 1C, we have a bunch of different angles, obviously. None of them are the same. And so they're all less than 90 degrees, though. So that, again, would be an acute triangle. And then, again, the sides opposite of those would all be different because our angle measures are all different. And so that would be another scaling triangle. Now let's go ahead and look at D. We do notice that we actually have an obtuse triangle in this case because that value is an obtuse angle. So we have an obtuse triangle. And at the same time, we do notice that those tick marks is indicating, we only have 2 of them, that this is an isosceles triangle. So that would be for 1D. Moving on, we've got 1E. We do notice that it is a right triangle because we have that little, right angle mark there. We're talking about a right triangle in terms of the angle measures. And then, because of those 2 tick marks, we do see that it is, again, an isosceles triangle. Now, for our next one, we notice that all of these different angle measures are less than 90 degrees. So that would be an acute triangle again. And to be a little bit more specific, because all of those angles are really the same, that's that equiangular triangle. So they really are acute, but to be a little bit more specific with our definitions, it's going to be equiangular. And now, because all of the sides are exactly the same with those tick marks, that is that equilateral triangle. Okay. And then last but not least, we have our right angle right here. So we have a right triangle. And looking at the side lengths opposite of those, because all of those angles are different, the side lengths opposite of those will all be different. And so that would be a scalene triangle. So again, really all we're doing here is just using our definitions to help classify those. Okay. Again, though, that is example 1 from our classifying notes, classifying triangles notes.